Hello everyone, welcome to our lecture. In this lecture, we discuss about the questions which are asked in first internet test 2K25. We have the question to write algorithm to accomplish the task of the following polynomials in a given following table. We have some tasks to evaluate the polynomial using iterative method, evaluating a polynomial using recursive method, polynomial division using synthetic division by x minus r, and finally computing the derivatives of polynomial. Let's begin with iterative approach to evaluate a polynomial of p of x. Firstly, we initialize the sum of variable s to 0. Then we go through each term of the polynomial starting from highest degree. For each term, we multiply coefficient with x and raise the power of the degree, and the result is added to the sum of s, which is sum is denoted by s. Finally, after odd terms process, s holds the value of the polynomial at x. Now let's look at the recursive approach for evaluating using a recursion relation. If the degree of the polynomial is 0, we simplify the constant term. Otherwise, we call the function recursively with the polynomial of degree n minus 1. Then we compute the value of the current term coefficient multiplied by x to the power of degree. Finally, we add the value to the results from the recursive call to return it. This method is elegant and follows the mathematical definition of polynomial quite closely. Now let's discuss polynomial division by x minus r. Firstly, we initialize the quotient q and remainder r to 0. For each term from highest to lowest degree, we divide the coefficient by x minus r to get the current term of the q. We multiply the quotient term with x minus r to find the what needs to subtract. We subtract that from the current term of the polynomial. The result becomes the part of the remainder r. Finally, we return the both quotient and remainder q and r respectively. There is a key note. This algorithm help us factor polynomial and find the root efficiently. Lastly, we compute the derivatives of the polynomial. We start initializing the derivatives of polynomial d to 0. For each term, we multiply the coefficient by the degree, then decrease the degree by 1, and the result d as the new term. We repeat this for all the terms, and finally the result